This is introduction to Coulombs Law, how to use the formula, and also most of the video is not going to be contributed to the Coulombs Law. It's going to be mostly contributed to Ohms Law and how to solve circuits. But I'm going to start with Coulombs Law, and if you need more videos on Coulombs Law, explanation and charges, I have a link attached to the video. So for Coulomb's law, the formula is between the two charges, the force of attraction or repelling force between two forces. The formula is KQQ over R squared. And Q1 and Q2 are the charges measured in coulombs, and K is Coulomb's constant, where the epsilon sub 0 is electric permittivity constant, and in the vacuum it's this number. And so if you plug into the formula for K, you get K is equal to almost 9 × 10⁹ Newton meter squared per Coulomb squared. So I'm gonna look at some of the questions involving this formula. So I have a few for you prepared to look at. So here's the first question from our online lessons. Two charges are separated by 3 centimeters. Object A has a charge of 6 microcoulombs and object B has a charge of 3 microcoulombs. What is the force of an object A by object B? Do they repel or attract? So Coulomb's law says the force of attraction or repelling is equal to K, charge of the first one, charge of the second one, the distance between them squared. K is 9 × 10⁹, and charge of the first one is 6 microcoulombs, so that's 6 × 10⁻⁶. And charge of the second one is 3 × 10⁻⁶. And the distance between them is 3 centimeters, so that's 0.03 squared. If I plug in my numbers, my answer is going to be 180 newtons. If you get positive answer, that means they repel, because if you have both positives or both negatives, your answer is always going to be positive. So that means two charges repel, or if they're giving you that it's a positive and it's a positive, you know the answer is going to be positive and it's going to repel in force. Here's another question that I'm going to solve for you just for practice. So I need to find the force between two charges. One is charged on -2 × 10⁻⁴ coulombs, and the other one is 8 × 10⁻⁴ coulombs, and they are separated by 30 centimeters. So the force of attraction is equal to K, Q of the first one, charge of the second one over the distance between them squared. K is 9 × 10⁹. Charge of the first one is -2 × 10⁻⁴, and charge of the second one is 8 × 10⁻⁴. And the distance is 30 centimeters, which is 0.3 squared. And it looks like the force of attraction between these two is going to be 16,000 newtons. Here's another good example to look at. A strong lightning bolt transfers about 20 coulombs of charge to Earth. How many electrons are transferred if one electron is -1.6 × 10⁻⁹ Coulomb? So you have 20 coulombs. It's like a proportion problem, not even like physics problem. So you have 20 coulombs, and you do not know how many electrons they are, but 1.6 × 10⁻⁹ coulombs is 1 electron. So if you have a proportion like this, what you do is cross multiply, then that gives you 20 electrons is equal to, I should say coulombs times electrons, or just 20, let's say this way, and then equals to 1.6 10 to the negative 19 times x. So x is equal to 20 divided by 1.6 10 to the negative 19. It looks like that will give me 1.25 10 to the 20th electrons. That should be electrons right there. I also want to look at these questions because they are often require your understanding on what is happening in the problem in order to be able to answer the question. It's not like a regular question type of problem. So two charged objects have a repulsive force of 0.8 newtons. So I'm solving 16. So I have the force that is equal to 0.08 newtons. If the distance of the separation doubled, then what is the new force? So I have K, Q1, Q2 over the distance squared. So that is what my original question was stating. Now what's going to happen, I'm going to double my answer or my distance. When I square that, I'm going to get 4d squared, and still have Q1, Q2, and K. So what I see here is, let me erase that too. What I see here is this. All this is 0.08. So all this is 0.08. So the new force, and I'm gonna mark it like this, is equal to 1/4. The new force is 1/4 of it. So that means it is 0.02 newtons. For number 17, two charged objects have a repulsive force of 0.08 newtons, or 0.08 of a newton. If the distance separation of the object is 1/3, then what is the new force? So again, I'm going to write the force is equal to K, Q1, Q2 over the distance squared, and that is equal to 0.08. So I know all this is 0.08. The new changes that appear is the distance. The distance is actually now 1/3 of the one that used to be. So it's 1/3 of it, and then it is squared. So I have still K, Q1, Q2. That gives me still K, still Q1, still Q2, still distance squared, but when I square, I have to square both of those. What I get is 1/9. And I know that this part is equal to 0.08. So this part is equal to 0.08. What I have now is 0.08, and I have 1/9 on the bottom. So the new force is equal to 9 times 0.08, which is 0.72 newtons. I'm going to solve for you also a few questions related to electric field. So electric field, if you have positive charges, electric field lines coming out of it. If you have negative charges, electric field lines coming into the negative charge. So here's a question. A point charge Q is far from all other charges at the distance of 2 meters from Q. The electric field is equal to 20 newtons per coulomb. What is the electric field at the distance of 4 meters from Q? I'm going to use the electric field formula. And Q is the test point, the one that I'm going to place into the field where I'm testing electric field to be 20 newtons per coulomb. But the source is Q, the big Q that they give you in this problem. That is the source, not the test point. So I'm gonna solve for F, plug in the Coulombs Law right here, and have electric field is equal to, instead of force, I'm gonna have Coulombs Law. So I have K. Q is the source, and then let me write it the way they give it to you. So it's this one, and then the test point where I'm testing how strong the electric field is at that point, distance squared, and all of it divided by Q. So this is where I'm measuring my electric field to be. It looks like I can divide it by, so I have a fraction, I'm going to rewrite it for you. So I have KQ QT divided by D squared, and then I divide by QT. That's the same as KQ QT divided by D squared and times over QT. So test point Q cancels, and I have electric field is equal to KQ over D squared. So I'm going to look at this equation to calculate the new electric field. So I'm going to look what changed to my equation. So what I see is before the distance was 2 meters, now the distance is 4 meters. I'm going to double the distance, so I'm doubling the distance because the distance is double compared to the ones that I used to have. So my electric field now is equal to KQ over 4 D squared. But the original part, this one, was given to be 20 newtons per coulomb. Then the new one is 1/4 of it, which is 5 newtons per coulomb. For this question, a negative charge, and they give you the charge, 2 × 10⁻⁸, experiences a force of 0.06 newtons to the right in an electric field. What is the field magnitude in its direction? So I have a negative charge. Let's say I have a negative charge, and it experiences the force to the right. So there is a force acting on it to the right, and I want to calculate the electric field at that point. So the electric field is equal to the force per charge. They give me the charge and they give me the force, so that's 0.06 divided by 2 10⁻⁸. Looks like that is going to be equal to 3 10⁶ newtons per coulomb. And because it experiences the force acting on it to the right, that means the right side must be positive or have some positive charges there, and so the charge feels attraction that way. Then the negative side is on the left side, and then electric field lines go from positive to negative. So the electric field direction is to the left. And here's the Ohms Law. So the voltage, and I suggest you to watch videos, conceptual videos, before you watch this one. So it would be easier for you to understand. I'm going to post all the links related to Ohms Law underneath this video in the description. So the voltage is equal to the work needed to be done on the charge to move it a certain distance from one position to another. And So that is the work done per charge. Voltage is measured in volts. We don't have to use this formula for calculating the voltage and current in the circuit. Sometimes voltage also is called potential difference or electric potential difference. And it has a formula in Ohm's law as I equal to R, IR. V is equal to IR. And I is the current, so I is a current measured in amps, so it measured in amps. And R is the resistance of the material through which current is going to flow, and measured in ohms. And V is equal to IR. Some of the books you will see these triangles that try to help you to remember what is what. They have triangle, this is for the power, but they have triangles where they tell you that the V and you have IR. But then V is equal to I times R, I is equal to V over R, and R is equal to V over I. I try to avoid these, but I still show them to the students. I don't use them that much in the classroom. So all you have to know is the Ohm's law. If you're looking for the potential difference of the voltage, you need to multiply the current by the resistance. And I'm going to explain it to you the way I usually do in the classroom. The students like my explanation, so that's why I'm going to post it here so you will be able to see it this way. Also, the power, when you buy a bulb, it has like 60 watt or 10 watt or 15 watt bulbs. It's power, so the watts is power, and the power is equal to, another formula here, the power is equal to IV. I can replace V with I times R. Then another formula for the power could be I squared R. Or I could replace I with V over R, because I is equal to V divided by R. Then I would have power is equal to, instead of I'm going to have V over R times V. So you could have power is equal to V squared over R. So good formulas to know. Also, when you solve circuits, they're usually going to be connected in parallel or in series connection. So I'm going to show you some examples for series and parallel connection. And then I'm going to come back to this chart and explain it more in details. So if I have a resistor, let's say 2 ohm, let's do it this way. If I have a resistor, 2 ohm, and a power supply, the battery, which is voltage, and then I'm going to call it 12 volts. The longer part of the battery represents the positively charged side, and the shorter one the negative charged side. So this is the positive, this is the negative. The current always goes from positive to negative. They didn't know the current initially when they chose the direction, and then when they did find out the direction of the current, they just left it as it is. So the current is going to go from positive to negative. In reality, it goes from negative to positive. But in circuits, we always show it from positive to negative. So here is your current. And I can use Ohm's law, which is V is equal to IR, to calculate the current in the circuit. So the current is equal to V divided by R. So the current in this circuit is equal to 12 divided by 2, which is 6 amps. What does 6 amp mean? So if you have a wire and there is an eye observing the wire, looking at the wire, there's some point. Imagine that charge is some bucket of electrons. So let's say like 1 coulomb, right? So there's many electrons inside of the bucket. So that bucket of electrons is called coulomb. And there's so many of them passing that point that the observer is looking at. So the current is, like, let's say 6 amps. That means there will be 6 coulombs passing that point per 1 second. 10 coulombs would mean there's 10 coulombs passing that point in 1 second. And when I say coulombs, I mean the buckets of electrons. Let's look at the different question. So now I'm going to have another resistor. So I had 2 ohm resistor. Now I'm going to have two 2 ohm resistors in my circuit. And I still have 12 volt battery. So I still have 12 volt battery. These two resistors connected in series, one after another, series. So if they're connected in series, I just can add them. So my total resistance, sometimes you will see like a summative sign, the sum of all the resistors in the circuit. So the total resistance, or you can see something like R total resistance is equal to the sum of these two, which is 4 ohm. So my total resistance is 4 ohm, not 2 ohm like it was in the previous question. So the current, again, is going to flow from positive to negative. And I want to calculate what the current is equal to. So it's the V divided by R. V is 12, R is 4, and I have my current equals to 3 amps. So what does 3 amp mean? 3 amp means that if there was a wire and there was some specific point that I'm looking at, or let's say the observer is looking at an eye. So the observer is looking at this point. When I say coulombs, I mean it's the buckets of electrons. So if I say 3 amps, I could say there are 3 buckets of electrons past this point in 1 second. So this would be like 3 buckets of electrons passing in 1 second. So that the definition of the current is how many coulombs, or how many charges pass in a point in 1 second. So I got 3 amps in this case. I'm going to add another resistor into my circuit in series. So there's another resistor. Now I have 3 resistors. This is the same 2 ohm resistor. So my total resistance is now not 4 ohm, it becomes 6 ohm. And what does it mean, 6 ohm resistor? So that means I can throw all these resistors away and place just one 6 ohm resistor into my circuit, and my circuit will not know something has changed. It will still give me the same current, like the same current it had before I threw all 3 resistors away. Or actually, what is this current? Let's recalculate it. So now I have my total resistance is 6. Now my new current is 2. So with 3 resistors connected, I would have 2 amps. If I throw away 3 resistors and just place one 6 ohm resistor, I still have 2 amps current flowing through it. So this is again for series connection. For one of the connections, but there is also a parallel connection. So for parallel connection, resistors get connected not in series, like the one after another. This would be series, right? They get connected in parallel. So I'm going to have one resistor, and then I'm going to have another one resistor, and another one, and all of them are parallel. They actually connected to the same point in the circuit. So all these 3 resistors connected in parallel. And then I have my battery. But I'm going to do this question a little bit differently for you so you understand how it affects the circuit. So I'm going to do it at first before I connect my resistors in parallel. Let's do again 2 ohm resistor, and here I have 12 volt. So the current in the circuit would be equal to, in this case, 6 amps, because the voltage is equal to I times R, and I can calculate my current by V divided by R. That gives me 6 amps. Now I'm going to connect another resistor, and when I said 6 amps, that meant through this resistor I would have 6 amp current floating. Now I'm going to connect another resistor. So this one was 2 ohm. I'm going to connect another one, which is also 2 ohm. And when I have this 2 ohm resistor, now I have, let me show you something here. I have these 2 points. Let me call it A point and B point. If I have a battery, so here is the battery. And I connect a 2 ohm resistor. And then I connect another 2 ohm resistor in parallel. In series would be one after another, right? But I'm not connecting them in series. I'm connecting them in parallel. So if this is my point A and this is my point B, do you see that the voltage between this point and this point, let's say this is 12 volt, between this point and this point is the same as voltage between this point and this point, the same voltage is between this point and this point, or the same voltage between this point and this point. So no matter where I take it, the voltage on both sides of the potential difference between these two is going to be 12 volt. So the same between here and here it's 12 volt, between here and here it's 12 volt, between here and here it's 12 volt. And this is the same point as this one, or this is the same point as this one, because they are connected to the same side of the battery. So what looks like, if I have resistors connected in parallel, they will all share the same voltage. So coming back to this question, so I have the voltage between this point and this point, 12 volt, and for this resistor. But I also have the same 12 volt for this resistor. So it looks like I'm going to have 6 amps flowing right here too, because the voltage between this point and this point is 12, either for this resistor or for that resistor. So 12 divided by the resistance that they give you gives you 6 amps. That changes your amperage that leaves the battery. That gives me 12 amps now here. Let me look at it a little bit differently for you. I'm going to explain to you this way. When I talk about the current, I often will say not current, I will call them aliens. When I talk about the voltage, I'm gonna call it, this is the money on a certain planet. This is how much money they have. And when I talk about the resistance, I'm gonna call it a bridge. So that's the bridge between 2 points. So what happens is the aliens live in the house with so much money in their pocket. So every time, so if this is the circuit, and here is the resistor, and here is the resistor. So if I have 12 volt, that's how much money I have. My 12 volt gives me how much money I have. So when I pass the bridge, so my aliens live in, I don't know, maybe 6 amps left, 6 aliens left. Every time I pass the bridge, I will leave some money when I pass. So some money is going to be left there, some money is going to be left there. And by the time I get home, I should be done with all the $12 that I used to have. So all the $12 is going to be spent by the time I get back home. So again, aliens is amps, how many aliens live in. Bridges are the resistors. Every time you pass the bridge, you pay money. So when you pay voltage. When you pay voltage. This is how much voltage is dropped. And then by the time you get back to your original destination, it should be all the money should be spent. So the voltage, when those aliens left, there's 12 of them living now. When those aliens left, 6 of them went this way and the other 6 went that way through the other resistor. Then they combined together and still 12 aliens came back. Those who went this way, they paid $12 and went back. And the other ones also paid $12 and went back. They didn't pay different $12. They paid exactly the same $12 because they share same $12. It doesn't matter how they get home. This path or that path, they will both pay the same $12. I will finish this video for now because I'm approaching 30 minutes for the video, and I am gonna continue video in the second one. There's going to be more solution for the second problems, like more problems solved in a different video.